Okay, so this is a very quick demo of how the potentiostat works in its current state and how it interfaces with the Pi. I'm still working on writing the documentation, so once that's written, it'll be much easier to use. But as of right now, the code is stored in this GitHub repository, and the two main files are potentiostat.ino and csvlogger.py. Potentiostat is what runs on the TNC. So if we open that in Arduino IDE, I'd suggest installing the TNC board layout first. But then once you've done that, make sure you change the CPU speed to 720 megahertz and the USB type to dual serial. The program will not work without this. Then hit the upload button and you should be off to the races. Now to interface with the Pi, I've just connected it via USB. It's pretty simple. Just the TNC over here, connected to a Pi through USB. Now this Pi is connected to the Wi-Fi as well. So what I've done is I've set up something called Real VNC that allows me to remotely access its desktop from my desktop, which is much nicer. So what I've done here is okay, it's lagging a bit. Okay, anyway, I've downloaded the CSV logger file here. And, okay, it's in my downloads. You can see it over there. And you can see it over here. Now, the first thing you have to do is figure out what serial ports the TNC is using. You do this by running this command, python-m serial.tools.list_ports. As you can see, we have 3 ports found so far. And typically, if you see 2, where one is labeled 0, one is labeled 1, those are the 2 ports that the TNC is using. The lower port, ACM0, is used for reading data from the TNC. The higher port, ACM1, is used for sending commands to the TNC. And that's just for simplicity. Now, to run CSV logger, there are a couple command line arguments. The first is the read port, ACM0. The second is the write port. Then you have the duration of the test. In this case, I'm leaving this 5 seconds. Then after that, the sample rate of the analog pins, which is 10 kilohertz over here. After that, you have the PWM sine wave output. This number is its frequency, and this number is its sample rate. Now, to stay in accordance with Nyquist's sampling theorem, make sure you have a sampling rate that is at least twice the frequency. Now, if we run this, you can see it begins reading data from the TNC. And after that's done, it gets saved to output.csv. Yes. Now, I can show you the result of a previous run. Instead of sampling from the analog pins right now, what I'm doing is I'm running a counter in the background. That's just so I can verify that there's no data breaks or loss of data. As you can see, it's working pretty well. There's no errors. Now, to use this in a real application, with the actual data, what you have to do is change counter here to sensor value. But I haven't done that yet, as this is still a testing build of the potentiostat.